Hey guys, welcome to this channel Code Therapy. Today is the very first video on this channel. Hope you like it. So today we'll be learning about consistent hashing. So before learning about consistent hashing, let's see what exactly is a hash function. So a hash function is any random function, not exactly random, that consider this as a black box. So we give any input. This can be anything. The range is literally infinite. But whatever we get a deterministic set of output. So let's take an example. A very simple example of a hash function is a modulo operator. So let's say we have something like modulo 5. No matter what we put the value of x, we will always be getting output in the range 0, 1, 2, 3, 4. So this is a very simple hash function. Let's take another example. So say we have an input string s as a, b, c, d, e. So an example of an hash function can be sigma s of I into I plus 1 modulo, let's say 10, I ranging from 0 to length of s minus 1. Now we come to the next topic. We have, let's say, distributed systems. As you know that in today's world there are so much data that we cannot do with just a single server. We need multiple servers to process that amount of data. In a distributed system, we can use a basic hash function as a load balancer. So let's say we have a load balancer with a hash function as modulo 4, and we have request IDs 5, 15, 6, 8, 1 and 3. And 5 modulo 4 would give us 1, so this request would go to server 1. 15 modulo 4 would give us minus 1 means 3, so this would give s of 3. 6 modulo 4 would give us 2, this would be mapping to server 2. 8 modulo 4 would be 0, this would be mapping to server 0. 1 modulo 4 would be 1, this maps to server 1, and similarly 3 modulo 4 would 3, this would be mapping to server 3. So this can be a good example, but you see where the problem lies. The problem lies in the fact that whenever we are removing or adding a server, so let me copy the previous example over here. 5, 15, okay, it's already copied. 5, 15, 6, 8, 1 and 4. So 5 would be mapped to 1, 15 would be mapped to 3, 6 would be mapped to 2, 8 would be mapped to 0, 1 would be mapped to 1, and 3 would be mapped to 3. Let's say server 3 crashes for some reason and it's no longer present there. So we just have 3 servers, but any request whose modulo 4 is 3 would be failing in this case. So every time this situation occurs, we have to change the hash function. This is one drawback. Now let's say we have another drawback. Again, let me map this. 5 would be giving to 1, 15 would be 3, 6 would be 2, 8 would be 0, 1 would be 1, 3 would be 3. Let's say our traffic increased suddenly from, let's say, 100 requests to 10,000 requests per second. We decide to add 2 more servers, S4, S5. We can see the problem here that this modulo 4 would never let the range of servers get over from 0 to 3. So this server 4 and server 5 remains unused. So what we need to do, we need to change the modulo function again to modulo 5 and again over here to modulo 3. So these two are the main drawbacks of using just a simple hash function for the load balance as a load balancer. Okay, so let's come to the solution of the previous problem. As we saw that we cannot use a simple hash function to balance the load. Here comes hash ring. So in hash ring, what we do, we just hash the server. We can do anything. We can just the SHA-256 of the server, we can hash it like this, or we can use the port to hash it, or we can use any other thing. We basically keep any number of hash functions. So for simplicity, we are just keeping it 2 over here. What this does, this gives a mapping in the range of 0 to length of ring minus 1. Similarly for this one, 0 to length of ring minus 1. So we would be able to understand why we are doing like this. So let's say we have three servers meaning I have an example. Yeah, let's say our server 1 maps to 3, server 1 maps to 3, server 2 maps to 9, and server 3 maps to 15. What it does, instead of the direct one-on-one mapping, we are doing a range map over here. So for request IDs in the range 16 to 3, so 16 to 3 means 16, 17, 0, 1, 2, 3, 4, 0, 1, 2, 3 would be served by server 1. Similarly, from 4 to 9 would be served by server 2. From 10 to 15 would be served by server 3, and so on. Now we see there is a problem in this implementation. Suppose our server 3 fails. The server position 3, that means the server 1 fails. Let me just take another color. Okay, so green denotes failure, whatever. So what it does in this case, all the load that server 1 was handling initially would be now transferred to server 2. You see the problem over here? If this server fails, the load on server 2 would be doubled. There is a high chance that server 2 also fails because of the high traffic. And due to this failure, all the load from 16 to 15, I mean the complete load would be handled by server 3, leading to failure of server 3 as well. So this is the situation of a typical cascading failure. There is another problem. Now say, as the second example in the previous situation, our request increased multifolds from 100 to say 1000 or 10,000. We need to add 2 more servers. So let's say for now we are just adding 1 server. We are adding server at position 6. I mean the hash function gave our position 6 for adding the server. We can see server 1, this is server 1. This is server 2 from our example. This is server 3. And this is our brand new server. We can see the load on server 1 remains the same as it's handling requests from 16 to 3. I mean, load on server 3 also remains the same. The only difference is the load on server 2 is decreased on addition of 1 new server. We can see there is an uneven distribution of the load in this example. Okay, we saw the problem in the previous implementation. Initially, I told you that in consistent hashing, we use multiple virtual servers for a given server, but I showed the example with just a single server. The problems in the above can be solved if we use multiple instances of the same server. So let me just draw the hash ring over here. This is our white hash ring. Let me draw the positions somehow like this. Now we would be drawing the servers. So we have our server at position, let me number this also, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have our server at position 1, position 0. Then we have another server next to it. Then again we have our previous server, this is the second instance. We have another server. This is our third server. Now we have our fourth server. Let's have 2 consecutive instances of our fourth server. And now this server is remaining. Let me just put another. This is 12 and this is 13. Okay. Now we can see we have 2 virtual instances of each and every server. Now we will take example of 2 possible scenarios. One for removal of a server and second for addition of a new server. Now let's remove one server over here. Let's say I remove this green server. This green server is no longer operational. What we see? initially the request handled by the green server is now being distributed among this blue server and this ash server. There is, in the previous drawback we saw that all the load was dumped upon just a single server. Here this load is distributed among two different servers. So that solves one of our problem. Now let's say we have all our servers intact and the load increases suddenly. What we do? We need to add two more servers. Let's say we have our server over here, one instance, and another instance, let's say we have our server over here. Initially what we saw, due to addition of one server, just a single server got relieved somehow. We can see that addition of this red server is taking requests from both this ash server and also this white server. So our second problem is also solved over here. We can see that the number of virtual servers is not just restricted to 2. The more number of servers you add, the better it is, the better the distribution, and that's it. That's all for consistent hashing. Now let me revise consistent hashing for you once. What we did. Let me just clear the complete screen. We started with just hashing. What is a hash function? If you remember, hash function maps random input to a set of deterministic output. Then we saw how we used a simple modulo operator as a load balancer. We saw the disadvantages of it. Disadvantage was whenever the server was down, we need to change the load balancer. Whenever the new server was added, we need to again change the load balancer. This problem was solved by the hash ring that we had, where instead of just mapping one-on-one, we are mapping the complete range of requests to a specific server. The problem of this one was whenever a single failure, there was cascading failure, and also whenever we were adding a new server, just one server got relieved. The solution to that was, instead of a single instance, we were now using 2 or more instances for the same server, as we saw. In this case, what happened? Whenever one of our server was failing, the load got distributed between 2 different servers, and similarly, whenever we were adding new server, the load got distributed also among 2 different servers. So then we can improve this by creating more number of virtual servers for this one. Okay, so that's it for the video. Thanks for watching.